The second kind of differential equations that we will study in section 2.6 are the Bernoulli equations. A Bernoulli equation is an equation of the form dy over dx plus ypx, or you can say y times a function of x, equals y power n times another function of x. Now, if you recall, this might remind you of a linear differential equation where we had dy over dx plus ypx is equal to, but then on the right hand side of a linear equation, we don't have y power n, we just have q of x. So y times a function of x equals another function of x. So this extra y power n here makes it a Bernoulli equation. Now, if n is equal to 0, of course, then this goes away and it becomes linear. And if n is equal to 1, then also it's linear, because n equals 1 means you'll just have a y here, yqx, and here you have a ypx, and then you can bring this over on the left side, factor out the y, and the px minus qx is just a function of x. And so you could have, you could write that as y times function of x equals 0. And 0 can also be treated as a function of x. So then also it becomes linear. So the bottom line is, when n is equal to 0 or n is equal to 1, then this just turns into a linear equation and there is nothing new. However, when n is greater than 1, then it's not a linear equation. And then let's see how we will solve the Bernoulli equation. So the way we solve it is we substitute v is equal to y power 1 minus n. And after this substitution, you can check it out. The Bernoulli equation turns into this equation. It becomes 1 over 1 minus n dv over dx plus v times p of x equals q of x. So the y to the n. So the point of this substitution is that this y to the n disappears. And now this is a linear equation, because this is just a constant which can be multiplied out, and then you have exactly the form of a linear equation. And so what we do is we solve this equation by the method we learned for linear equations. And then, of course, after the solution, you have to substitute the v back. And since v is y power 1 minus n, so from here, if you try to find y, you take the 1 over 1 minus n power on both sides. So y is equal to v power 1 over 1 minus n. So let's look at an example. Let's look at this equation. dy over dx plus y over x equals 3x squared y squared. So we recognize that this is a Bernoulli equation, because Bernoulli equation is dy over dx plus y times px. So we have y times 1 over x. 1 over x serves as the px. And then on the right-hand side, you have y to the n times a function of x. So here we have y to the 2 times this function of x, which is 3x squared. So q of x is 3x squared. P of x is 1 over x. And n is 2. N is the power of y. Okay, so then as we said, the substitution is v is equal to y power 1 minus n. So in this case, it would be y power 1 minus 2 is equal to y power negative 1. And then you can either do this substitution and figure out what you get, or you can just remember that after this substitution, the equation becomes 1 over. It's much more quicker if you just remember that after this substitution, y is equal to v power 1 over 1 minus, v is equal to y power 1 minus n. The Bernoulli equation turns into this equation. So 1 over 1 minus n dv over dx. So n is 2, so it will be 1 over 1 minus 2 dv over dx plus v times px is equal to qx. So px and qx are unchanged after this substitution. Here, remember, we had a y, so y becomes a v, and here we had a yn, which goes away. So we just have 3x squared and v 1 over x, 1 over 1 minus 2. And now you can put it exactly in the linear form, because remember the linear form, let me show you what it was. The linear form was dy over dx plus y times a function of x is equal to a function of x. So the way we knew the linear equations was dy over dx was standing alone plus y times a function of x equals a function of x. So let's go back. So that's why here this thing is 1 over 1 minus 2 is 1 over negative 1, which is negative 1. So to clear the negative from the dv over dx, you multiply everything by negative 1. So this is dv over dx. This becomes v times negative 1 over x, and this becomes negative 3x squared. So now you recognize this is exactly linear. So then if you remember what the way was, let me just show you what the way was to solve the linear equation. You first find the integrating factor. Integrating factor is e power the integral of this function that comes with the y. So in this case, the integrating factor will be e power integral of whatever comes with the y, which in this case is whatever comes with the v, is equal to e power negative ln x is equal to e power ln x power negative 1 is equal to x power negative 1. Or just 1 over x. So after you find the integrating factor, and let's recall what the next step was. Then the solution is y is equal to 1 over the integrating factor times integral of integrating factor times g plus c. So 1 over y is equal to 1 over integrating factor. So solution is y is equal to 1 over the integrating factor, so 1 over x times the integral of integrating factor times the right hand side, which is negative 3x squared plus c. Yeah, I times the g was the right hand side, which in this case is negative 3x squared. And then this simplifies to x integral of negative 3x plus c, and that integral is negative 3x squared over 2. Is equal to negative, so you can leave it like that, or you can write it as negative 3x cubed over 2 plus cx. We get a y. So this is a solution. Well, not quite. Okay, there's a tiny error here because instead of a y, we had a v. So all this was not a y, but a v. But now you substitute back, v was, so you can just remember, so you substituted this one, where was it? So you substituted v is equal to y power negative 1. So v was just y power negative 1. Negative 3x cube over 2 plus cx. And then you can find y from here. You raise both sides to power negative 1. X cube over 2 plus cx power negative 1. So that is the answer.